Alright guys and gals, I'm going to give you a crash course on naming ionic compounds. Ionic compounds are between a metal and a nonmetal, but in case you don't remember, here's a periodic table, and so we can see that the stair-step line right here, which has metalloids all along it, everything to the left pretty much, except the things along the stair line, these are all metals. Everything over here, except the ones on the stair line, those are non-metals. Metals make positively charged ions. Non-metals make negatively charged ions. Ions together, ionic compounds. Get it? We're going to talk about a couple different things. First, we're going to talk about ionic compounds that do not include these transition metals in here, and then later in the video, we'll talk about how the transition metals are slightly different. Okay? So everything that is not in this box right here has a standard oxidation number. So later on we'll talk about why that doesn't work here. But this is just naming, so this should be fairly easy. So all we got to do is, first I got to find the right piece of paper. Let's go back to tan. Yes, that looks great. So naming an ionic compound, very simple. You got to first recognize that you have an ionic compound. So you go, okay, hey, I got sodium and I've got chlorine, metal, non-metal. It's ionic. All you have to do, the metal name doesn't change. The non-metal name gets an IDE ending. So you get sodium chloride instead of sodium chlorine. Pretty easy, right? What if you have something like CaOH2? Ooh, see a polyatomic ion in there. Does that make a difference? Well, kind of. Still, the metal name remains unchanged. So you've got calcium. We don't have to do anything different to the polyatomic name. So the polyatomic OH is just hydroxide. So therefore, we're going to say hydroxide. Pretty easy there. Let's look at another one real quick. This is a good example. NH4. NO3. This is an ionic compound made up of two polyatomics. So this polyatomic is the positive one, this one is the negative one, so we know it's ionic. That's all nonmetals together, which may look like covalent at first, but you have to remember your polyatomic ions so you don't get tripped up. So we just say the names of the polyatomics. NH4 is ammonium, and then the NO3 right here is called nitrate. Ammonium nitrate. No special things to do to the ending with polyatomics. The IDE ending, ide, is only done when the anion, that's the one on the right, is just an element, like chlorine or oxygen or something like that. So that's pretty easy when you're just naming normal polyatomic or ionic compounds and polyatomic ones as well. Let's talk about if we have one of those transition metal ones in there. So what we have to do here is if we're naming, say, Fe2O3. Okay, this is kind of tough. We know this is iron, and we know this is going to be oxide. But the problem is there's a bunch of different iron oxides. Okay, iron is in the transition metals in the middle of the periodic table, that portion. So we have to figure out what charge iron is using. So kind of remember back to what we were talking about with everybody has a certain charge. Oxygen's charge is always -2 because it's 2 away from being full with like the noble gases. It only needs 2 more electrons to look like a noble gas. So it's going to gain those 2 more. So if we've got -2 for oxygen and there's 3 oxygens, that's a total of -6. So with iron, we have something times 2 irons has to give us +6 to cancel it out. And so it would be +3, right? So we're saying in this case, iron is using a +3 charge. So we say iron 3. We use the Roman numeral 3 and do it like that. Pretty easy. Do one more. Let's find another one that's in the middle there. Let's say we've got SnSO4. So tin is actually, it's kind of a post-transition one, but I want to make sure you understand that tin and lead also have multiple oxidation numbers, multiple charges. So let's look here. I know tin is the positive, and then we have SO4, which is sulfate. All right. So what charge is tin using? Well, we've got one sulfate here that's a -2. And then that means our tin, there's only one of them, has to be a +2 to cancel out that -2. So this would be tin 2 sulfate. You'll get this, you'll practice it, you'll be fine. If you're confused, just talk to me, talk to your team, and we'll see if we can't get through it.